Hello dear students, let's start the revision part 1 of chapter 6, study of the first element hydrogen of class 9th in subject chemistry. Let's open your chemistry book and come on the page number 99. So revision about the hydrogen. The symbol of the hydrogen is H. The relative atomic mass of the hydrogen is 1. Molecular formula of hydrogen is H2. And relative molecular mass of hydrogen is 2. Atomic number is 1. Valency is 1. Electronic configuration of hydrogen is 1. And there are 3 isotopes of the hydrogen. Hydrogen 1, hydrogen 1, 2, deuterium, hydrogen 1 and 3. Tritium or heavy water, radioactive water, hydrogen, not heavy water, radioactive hydrogen. Now, the position of hydrogen in the periodic table. So, it is a question where the hydrogen is the suitable position in the periodic table. Hydrogen is the lightest and first element of the periodic table. It is the lightest of among all elements and it occupies the first position in the periodic table. Hydrogen contains 1 proton in its nucleus and just 1 electron in the K shell, that is 1 valence electron. Therefore, hydrogen should be placed in the group number 1 and the periodic and the first period of the periodic table, so due to their electronic configuration. Now, however, the proper position could not be assigned to it either in the Mendeleev periodic table or in the modern periodic tables due to the 2 reasons. Due to their reasons, number 1, in some properties it resembles group number 1 elements, that is alkali metal elements, and so it can be placed in the group number 1. But hydrogen is not a metal in the group number 1. All alkali metals are present, but hydrogen is not a metal, it is a non-metal. So, in some other properties, hydrogen resembles group number 17 elements or halogens, so it can be placed in the group number 17. So, the hydrogen can be placed in the group number 1 and it also can be placed in the group number 17. But where is the right position of the hydrogen in the periodic table? Thus, the position of hydrogen in the periodic table is a controversial or anomalous. Let's see, the hydrogen, right now the hydrogen in the modern periodic table is placed in the first group and first period in the periodic table. But the some properties of the hydrogen is resembles with the alkali metal and some property resembles with the group halogen elements, group number 17 halogen elements. Now, the resemblance of hydrogen with alkali metals. Some property of hydrogens resembles with the alkali metal. In number, electronic configuration. Hydrogen as well as alkali metals have 1 electron in their valence shell. Hydrogen also have the 1 valence electron, 1 electron in the valence shell. If you consider sodium, then 11 atomic number, then 2, 8 and 1. So 1 electron in the valence shell in case of sodium. Now, ion formation. Hydrogen form H plus ion like the alkali metals, lithium, sodium, potassium, or lithium, sodium, potassium form the lithium plus, Na plus, K plus, and hydrogen also form the H plus ions. Now, the valency electron, like the alkali metal, hydrogen also exhibits valency of 1 in its compound. Sodium have the one valency, hydrogen also have the one valency. Combination with non-metals. Like alkali metal, hydrogen combined with non-metals such as oxygen, chlorine, and forming their respective oxide and chlorides. As for example NaCl, as for example HCl. Now the reducing action. Like alkali metals, hydrogen is a very good reducing agent, and they have the ability to provide the electrons or donate the electrons to the other elements or compounds and reduce to them. Now the resemblance of hydrogen with halogens. A number. Valency electrons. Like the halogen element, hydrogen needs just one electron to attain a stable inert gas configuration, that is one valence electron. So halogen elements also needs just one electron to attain their stable inert gas configuration. Hydrogen also just needs one more electron to attain the stable inert gas configuration. Now the valency of halogen is 1 and the valency of hydrogen is also 1. Now the non-metal. So hydrogen is a non-metallic element like the halogens. Atomicity. Hydrogen as well as halogen are diatomic gases. As for example H2, Cl2, Br2, Tc. Combination with metals. So halogen also combined with the metal and hydrogen also combined with metals. So for example in the case of NaCl, the halogen Cl combined with the Na metal. In case of HCl, chlorine is a halogen and that combined with the hydrogens. Now NaH. So hydrogen is also a non-metal combined with the metal Na. Now the ionic formation. Like the halogen, hydrogen have also the tendency to gain one electron to form the hydrogen ions. It's hydride ion, it's minus ion. As like the chloride ion, as like the bromide ions, hydrogen also form the hydride ions by gaining one electron. Let's see the examples. Let's see the reactions. Hydrogen gain one electron form its minus hydride ion. Chlorine also gain one electron to form Cl minus. Thus, like the halogen, hydrogen exhibit electronegative character like the halogens. Now, hydrogen form ionic bonds with strongly electropositive elements. As for example NaH, CaH2 and covalent bond with electronegative elements H2O and HCl. So hydrogen form electrovalent bonds as well as covalent bonds. Isotopes of the hydrogens. So first, what is the isotopes? The isotopes, the elements which having the similar atomic number but different atomic masses. These all elements are called the isotopes. So hydrogen has the three isotopes. Protium is called the ordinary hydrogen. It has the one atomic number and one mass number, and their symbol is H11. So protium is also called the ordinary hydrogen. Deuterium called the heavy hydrogens. It has an atomic number 1 and mass number 2, and the symbol of the deuterium is H12. It means 2 atomic mass and 1 atomic number. Tritium is also called the radioactive hydrogens because it has the radioactive properties and has an atomic number 1 and the mass number 3, H1 and 3. Their symbols. Let's see the diagram. Protium, deuterium and tritium. Protium, all three have the only one electrons, but the number of neutrons in case of protium is 0, deuterium is 1, and tritium is 2. So their mass number have different 1, 2 and 3 respectively in protium, deuterium and tritium. So this is all about the introduction of the hydrogen and their position in the periodic tables. Okay, thank you, have a nice day.